When the sun releases an accumulated buildup of magnetic energy near its sunspots, it often results in an explosion of electromagnetic radiation called a solar flare. On other stars, we often observe this phenomena through photometric surveys like TESS or Kepler. Analogously, these are called stellar flares. The stars in the night sky that we see all come in many different forms. Some are hot, some are cold, some are heavy, some are light, and many of them are actually a lot like the sun. A study back in 2012 looked into stellar flares coming from these kind of stars not too different from our sun. The flares that they looked at were a special kind of stellar flare called superflares, which have energies that are 10 to 10,000 times more energetic than the flares we see from the sun. In total, the researchers found 365 superflares from 83,000 stars over a 120-day observation period from the Kepler Space Telescope. This figure from the study shows an example of these superflare events in action. The light curve shows the relative flux of the star, or the difference between the brightness of the star during these observations and the average brightness of that star for the whole period. These up and down modulations you see in the light curve are usually due to star spots on the surface of the star rotating in and out of view, causing the flux to change over time. The size of these star spots are directly correlated with how strong the flares from the star will be. As the larger they are, the more magnetic energy is built up, which is then converted into E&M radiation, kinetic energy, and thermal energy as the flare is released in space. This was a groundbreaking study as it set the stage for the next decade's worth of flare work from the space telescopes that followed. And as we've understood flares more and more, we've expanded our understanding of how stars impact their surroundings, such as the exoplanets that exist around them. Would you want to see one of these flares up close? Follow me for more astrophysics.